So the first thing is, a matrix is really just information. So we're going to do or solve a system of 3 equations by using a matrix. And you take a matrix by simply taking the coefficients from it. So you set up a coefficient, since there's these 3 and then a 4th one. So you're going to put 1, -2, and -1. You draw a line before you put the 2. These equal signs means that you put the answers to them all here. And otherwise it's just the coefficients. Nothing more than just write out the coefficients. And then we will solve this. Oops, let's finish that. This is called an augmented matrix, when it has the answer part of the 3 equations. So just a term for it, but you'll recognize, you'll see that written in places, so you want to be aware of it. I wrote that down here because now once you take those and you make a matrix, now you're going to solve the matrix. You can do the same thing by treating these as just 3 equations and doing like we did in an earlier section, I think it was 7.2, where you're solving the equations. And you just do the work to solve them and get rid of a z, or get rid of an x, or get rid of the y. But we're going to do the same thing here with these. So I want to walk you through it. If you already did these and are comfortable with it, great. But I think the experience of doing it would be a nice review. Or if you aren't so comfortable with it, then this will be a good thing to get used to. So what I'm going to do is treat these as 3 separate lines. I'm going to call this one line 1, and this one's line 2, and this one's line 3. My goal is to get this into a certain format. What I want to do is I want to get it looking like this. Okay, I'm going to set this up here. I want to have a 1 here. I want to have a 0, and a 0, and another 0. So that I'll end up with some number here, and then I'll have something here and something here, and this and something here and here. So actually the way this is done doesn't have to be 1s there. But you have to have this one a 0, this one a 0, this one a 0. So that 2 has to become a 0. That -1 has to become a 0. And that 1 has to become a 0. When you do that, this line is for the x's, to figure out what the x's are, what the x is. This line is to figure out what the y is. This line is to figure out what the z is. Now, if that's 0 and that's 0, that means this is 0 times x plus 0 times y plus whatever this is times z equals whatever this is. If these are zeros, you can now figure out what z is. Let's say that this was a 5. Let's pretend that was a 5, and that this was a 15. So you'd say 5z equals 15, divide by 5, and z is equal to 3. Then you would use it with this one to figure out what the y is. Then you would use both the z and the y to figure out what the x is. That's what we're going to do here. My problem is I need to make these zeros, and they're not zeros yet. So here's how we're going to do it. I'm going to look at this one and think, what do I do to make that a 2? Well, just like up here where if I was trying to use these 2 equations, I could see, hey, if I made this 2x and then subtracted, I would get a 0. Okay? So I'm going to do that here. I'm going to take this line, I'm going to multiply by a 2. Now, the thing is, I could do this one or I could do this one. I'm just realizing now, if I multiply this one by a 2, I get a -2 and I can just add them. So what I'm going to do over here is I'm going to take line 2, I'm going to add to it 2 times line 3. So I'm going to write that out. Line 2 is a 2, a -1, a 1, and a 4. So I'm going to use this side as my workspace, and I'm going to put the new one over here. Now, I'm going to take the line 3, and I'm going to multiply it by 2. -2, 2, -4, and 8. And I am now going to add these. So I'm going to add these two. 2 and -2 is a 0. -1 plus 2 is 2 minus 1, so it's a 1. -4 plus 1 is a -3. And 8 plus 4, oh, that's supposed to be, there was a -4, and so that should be a -8. I forgot that negative, good thing I caught that. 4 plus a negative 8 is a negative 4. So this is the new line that's going to go here. So L2 is going to get replaced. So I'm going to rewrite it now. 1, negative 2, negative 1 and 2. 0, 1, negative 3, negative 4, negative 1, 1, negative 2, and negative 4. So I use that, put it in here, and now I've got my first 0. I'm trying to get that one. Now I want to do this one. Well, getting this 0 is easy. Look right here. All I have to do is add these two. I don't even have to multiply them. So I'm going to take L1, and I'm going to add to it L3. So I have 1, minus 2, minus 1 and 2, minus 1, 1, negative 2, and negative 4. Add these. I get my 0. And I get a negative 1, it looks like here. Negative 2 plus 1, negative 1. This adds up to a negative 3. That adds up to a negative 2. And I'm going to put that right in place of it. So let's rewrite it again. Negative 4, add a new one. 0, negative 1, negative 3, negative 2. I have 2 of the zeros I want. This one's nicely set up so I can get this other 0 by just adding these two lines. I don't even have to multiply them again. So not that that was that hard to do anyway back here, but now it's even easier. I'll add those two together. So I'll do line 2 plus line 3, the new line 3 and the new line 2. 0, 1, negative 3, negative 4. 0, negative 1, negative 3, negative 2, and I'm going to add them. So it gives me 0. 1 minus 1 is also a 0. Here's a negative 6, and here's a negative 6. So I get 1, negative 2, negative 1 and 2. 0, 1, negative 3, negative 4. 0, 0, negative 6, negative 6. Now, back up here, I sort of wrote it out like this, because that's what we can now do with each of these. Now that I've got those zeros where I want, I'm going to rewrite these as 1 times x minus 2 times y minus 1 times z equals 2. This one is, there's no x, so I'll just do y minus 3z equals negative 4. And on this one, there's no x and there's no y, so I'll just do the negative 6z equals negative 6. And now that we've got to that point, this one, let's just solve for z. Divide both sides by negative 6. I now know that z is 1. Since I know that, I can put that 1 in here and figure out what y is. So y minus 3 times 1 equals negative 4. Y minus 3 equals negative 4. Add 3, and y is equal to negative 1. So I know that, and I know that. And now I can put both of these into this one. X minus 2 times negative 1 minus a 1 for the z equals, that's a 2. Okay? Move this up. So with this, we can find the x. X plus 2 minus 1 is equal to 2. X plus 1 equals 2. Subtract that, and it looks like we have x is equal to a 1. And now we know x, y, and z. We have to write the answer, since this is three-dimensional. 3 lines means you've got 3 planes, basically. You've got these 3 lines meeting at a certain point, and you have to put them in x, y, and z form. That's x, that's y, and that's z. This is not the correct way to show the answer. This is, so make sure you're careful on that. So let's review what happened here. Okay? And I'll come back down with it. So a system of 3 equations can be written as a matrix, and then that matrix, you can manipulate it by changing lines and adding or subtracting lines in order to get a 0, a 0, and a 0. And if you get those 3 zeros in those places, then you solve one of them, then it becomes easy to solve for the z. Use that to make it easy to solve for the y. Use that to make it easy to solve for the x. And then you get your answer for it. You can do the same thing by doing the 3 equations without using matrices. So this is really just a different method of doing it. There's actually usually 4 or 5 ways you can solve systems of equations. This one, and doing it with the 3 equations, are both sort of equally as easy or as hard. So I would call these 2 equal as the second easiest way to do it. First easiest way to do it is to plug it in the calculator with the right commands, and I will show you that in a few minutes. We're going to do 2 of these by hand, and then I'm going to show you how to do them on the calculator. So, well, let's do this again with the next one that has a little change to it. So this is one method, or one system. Now let's take a look at page 2. Okay. This one is almost the same kind of thing. Originally, this was 5x plus 3z equals negative 11, y minus 4z equals 12, and 7x plus 2y equals 3. Well, with the zeros in there, we're going to be able to manipulate it around. But one of the things I want to mention is that 5 up there. One of the goals you want to have when you do this is to try to make this one to be a 1. Because when you do that, you can use that equation with the other ones much more easily. For instance, if you look back over here, this one was already a 1. As a result, we could use it. Let's see, I didn't even use it that much in this one. We didn't really need to because the other ones were all 2s and 1s. But it's easier to do the thing when you have a 1 there. So what I'm going to do with this is, let's change that around to make that a 1. So I'm going to look here at these numbers. I can't use this one to help with that because anything I multiply to 0 is still going to be 0. So that's not going to do me any good. But I see this one is a 7. That one is a 5. If I want to make that a 1, I can find, like, not really a lowest common denominator between them, or a factor, greatest common factor, but rather numbers that are next to each other. If this were, say, a 20, and this was a 21, then I could do 21 minus 20, and I would get a 1. So what I'm going to do is I'm going to multiply this one by 3, this one by 4, and I'll get 21, and I'll get 20, and I can subtract that. So I'm going to do this. Remember, this is L1, this one's L2, and this one's L3. So I'm going to do L3 times 3, which is 21, 6, 0, and 9. And then I am going to do this one, L1, I'm going to multiply it by 4. Because 4 times 5 gives me, that's now 20. 4 times 0 is 0. 4 times 3 is 12. And 4 times negative 11 is negative 44. And now I can subtract. 21 minus 20 is 1. 6 minus 0 is 6. 0 minus 12 is negative 12. And 9, minus is plus, so it looks like that's going to be a 53. Big number, but we can work with it. Now that's a 1, and we'll find that we're going to use that to help with some of the other ones. So let's take it and let's replace it here. 1, 6, negative 12, 53. That replaces that one. 0, 1, negative 4, and 12. 7, 2, 0, and 3. That one being a 1, it's going to help us to get this one out of there and change the 7 into a 0. Because remember, we want a 0 here, a 0 here, and a 0 here. This one's a 0 right now. Well, that can change, and it will probably when we work with this. So let's see what happens. So right now, if I want to get that out of here, I need a negative 7 to add to it. We can take this one and multiply it by negative 7. Then we'll have a negative 7 plus a 7, and we get the 0 that we want there. So I'm going to take L1, and I'm going to multiply it by negative 7. And that gives me negative 7 here, negative 42 there. Okay, now we've got a bigger number. We're going to do negative 7 times negative 12 is going to be a positive 84. And then negative 7 times 53 is going to be a negative 371. I know those not because I'm great at multiplying, even though I think I'm pretty good, but because I have them written down and made sure I did this right before you guys came in. So we got a -7, -40, -7, -42, +84, -371. So it's -7 times all that. Now, next, I'm just simply going to write this one underneath it, L3, and then I will be able to add them. So we get 7, 2, 0, and 3. -7 plus 7, I got my 0. And here I get a -40, here I get an 84, and here I get a -368. Okay, -368. Now, interesting thing. When I did this, I did it a little differently. So take a look at this because you can see there's different ways to do it. I just multiplied by 7, and then I subtracted. So I multiplied the second one by 7. They were all positives and negatives the other way. But when I did that, I still ended up with the numbers that I needed to have here, except I don't think I wrote negative. I did negative there, I did put it over here. So I ended up with the same thing. So there are multiple different ways to do it. Like on the first one, I ended up with positive here. If I had done it where I had the 21 underneath and subtracted, I would have had a negative for that, and then multiplying by -1 for everything would have made it positive. So I avoided that this time when I did the problem by doing this. I ended up setting it up so I would subtract and get the positive in the first place. But this shows that there's multiple ways to do this. All right, now let's put it in there. 1, 6, -12, 53. 0, 1, -4, 12. 0, -40. 84, -368. Well, we're going to do the same thing. Now we need this one to be a 0. Okay. I can't do 6 times anything to get a 40, but I can do 1 times 40. So we can use bigger numbers like that. We're going to have to do this times 40 and that times 40, but so what? Let's do it. So what I'm going to do is 40 times L2. 40 times 0 is 0. 40 times 1 is 40. 40 times -4 is -160. 40 times 12 is 480. Then I'm going to take L3, and I don't even have to do anything to it. I can just put it underneath because it has the -40 that I can add here and get rid of it. This one's an 84, and then -368. And now we can add 0, 0. -160 minus 80 would be -80, but it's 4 more, so it's -76. And then 480 take away 368 is 112. 1, 6, -12, 53, 0, 1, -412, 0, 0, -76, and 112. So I have the 3 zeros the way I want it. So I'm going to write these out, and then I'm going to solve that one and plug it into the others. That's 1 times x plus 6 times y minus 12 times z equals 53. This one is no x, but it's 1y minus 4z is equal to 12. And this one, no x and y, it's -76z is equal to 112. When you divide that 112 by -76, you get z is equal to, and you get -1.47. So it's an approximate. Let's take a look at that. Clear it, okay. So I have 112 divided by 76, and it's negative. You notice you get big decimal. It's okay to use decimals for this. You round it. The reasonable place to round it is usually to the hundredths place. So I made it 1.47, and since it's a negative, I had to put the negative with it. So we'll use that now, even though it's that. You can do this with fractions. When I did this and solved it, I set it up with fractions where we would have -112 over 76, which would reduce anyway to -28 over 19. If you prefer that, you can do it, but frankly, decimals are easier. Now let's plug that in with the this one. So we know the z, let's use y minus 4, negative 1.47 equals 12. And when you multiply that one out, I did it with fractions before, but we'll do it now. Y plus times 4, 5.894, so it's 5.89 equals 12. And then subtract it, and we get a y is approximately 6.11. Oh, negative 6.11, is that right? Is it negative or is it positive? Nope, it's positive, because it's 12, take away that. So approximately 6.11 comes to negative 6.105, so that 5 will round to 0 to a 1. And it's negative here, it's not supposed to be. I recognize it's got to be a positive. So now we know the y. Well, we also know the x's here, so it's going to be x times or plus 6 times 6.11 minus 12 times negative 1.47 equals 53. It's a pain to do with all the decimals, but it's probably easier than doing it with the fractions. So 6 times 6.11 x plus 36.66, 12 times 1.47. So that's minus and minus, so it becomes plus 17.64 equals 53. So if you add those together, if you just 53 minus that, because I'm going to subtract that, I'm going to subtract that. 53 minus 36.66 minus 17.64. This is one of the places where you're advanced enough now in math that you could indeed add these together and then subtract it one time. You also see what's going on. You can do subtract this from it and subtract this from it, just do it all at one time. So it's 53 minus 36.66, because we move it over, minus the 17.64, and I get negative 1.3. So x is approximately negative 1.3. Negative 1.3, 6.11, negative 1.47. So yes, you can have decimals or fractions. If you had this one as an approximate solution, because we put it in decimals, if you were required to do as an exact one, you would have ended up with these fractions. But at this point and at this level, approximating it, doing it decimals makes more sense when you have these kinds of weird fractions that are irrational, never-ending, never repeating. It appears. Okay, so in a way, what we did here and what we did here are exactly the same. The difference is this one gets a little more complicated, but as long as you're careful with your calculator and your decimals, you should be fine. Okay, now, there is a third one here that you may practice on your own. When I post this in Google Classroom on Friday, I'll have this one written out. So you will have to do one of these by hand. But after that, after you do them by hand, you need to be able to do them on a calculator. So I gave you a page here showing how to do it, explaining it. We're going to do it on the calculator. So if you have your calculator, please take it out. If you don't, then watch and just make sure you're aware and practice it at home. So I actually think I have to clear some of mine too. So hold on and let me do clear. So the way to clear it, I have at the bottom of that, which is good because I don't always remember it. So I'm going to make sure I do all of the ones. It actually has a place on here to clear matrices. Okay. And I have right now 5 matrices being used. So I want to do delete, 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 delete. Okay. So I'm only clearing my matrices. But now, here's how you get to them. So that's, by the way, I put that on there because after you do, if you practice a bunch of these, you're going to find out you fill up all the matrices and you need to do new ones. So now you know how. Follow what I put on the bottom. So here, we're going to follow this, but I've been doing it for a while, so I'll show you. There is a matrix key. That's the second function for this x minus 1 key. So press second, and where matrix is. So right here, these are if they're already completed. We want to enter a matrix, so you need to go over here to edit. So use the arrow key to go over to edit, and then press 1. Let's do the A one. And let's take the first problem that we had. Okay. So it became this matrix here. So what I want to do is enter that matrix, and there's two parts to it. Up at the top, we have to tell it what its dimensions are. So remember, that's rows by columns. This one has 3 rows, and it has 4 columns. So you do a 3, press enter or the arrow key to move over, and then 4. And then press enter. So put 3 times 4 up there at the top of it. And then after you pressed enter, you're ready to enter numbers. So put a number in, press enter, and it automatically moves you to the next one. So I put in the 1. Be careful because the calculator knows the difference between the minus key and the negative key. So if you were to put in the minus key and try to put the 2, it's going to say, yeah, I got a problem. Syntax means you told it the wrong operation. It thinks you're trying to subtract when all you're trying to do is enter a negative number. So I'm going to go back there to it. Matrix, edit, number 1. Okay, so now I can go back to that spot and use the negative key instead of the minus key. Okay? If you already were aware of that and comfortable with it, great, but I see people really struggling, not sure what to do, what's wrong, so I wanted to make sure that you saw that. So I entered these 4. The 4th one's hidden just because we use so much space in there, but we can live with that. -1, 1 for there, and then the last one on that second row. So enter them for all 3 rows. And when you get to the last one, there's a couple of ways to get out of it, but the easiest one is to do something like graph and then press clear. If you just press clear, it's actually going to try to delete where you are. So clear alone doesn't do it. So you're pressing one of these other things and then clear. Mode also works too. So now that I'm back here, go back to matrix. Not edit, but on this one, press 1 and it will say the A matrix. Press enter, and you can see what you entered so you can make sure you have the numbers right. This is not required to do, but it's something I do often to make sure I didn't forget a negative or something else. 1, -2, -1, and 2. Oh no, I'm looking at the wrong one. I started looking there when I should be looking here. 2, -1, 1, and 4, -1, 1, -2, and -4. Good, it looks like I entered it correctly. So now that I have a matrix in there, I want to get to here. Okay, so I'm going to show you 2 keys. The first one you really don't need to do, right? And I'll show you why in a moment. Because the second one goes a little further. It gives you the answer and you don't have to do anything. Second in matrix, I'm going to go over to math, and it has a whole bunch of things, most of which we're not going to use, like ever. Some of them are good for statistics stuff, so if you take AP statistics or a statistics class in college, then you'll use them. REF, ref. I don't know why they use the letters ref, there's some reason, but I've forgotten. So I'm going to do this A1. And it's now looking for the name of the matrix. So I have to go back to matrix and choose my A matrix. I can put the parentheses, but I don't have to. And when I press enter, look at what it did. It didn't even do the 6z. It just did it for me where it divided both sides by the -6. So 1z equals 1, so z is equal to 1. But to find the y, I have to put that 1 in here and do y plus 1 equals 0, and then subtract the 1. And then I've got to put -1, -0.5 times -1, and 0.5 times 1 and solve for the x. I'll get the same answers. Nothing wrong with that. But watch what happens if you do second in matrix, math, and I'm going to go up to get to it. Look at this B1 that's double R, R ref. Using that one is the best one. And here's why. I'm going to put my A matrix. you don't have to do any solving. It just gives you the answer straight up. It tells you that since these are all other zeros, x is 1, y is -1, z is 1. There are your answers. You don't even have to do any of the other solving. That's why this is a really great tool for matrices. Yes, I'm going to make you do one by hand, but the rest of them, you just save yourself a lot of time if you're comfortable with putting them in there. The second that we did, I want you to go in and do the B matrix. I want you to enter this one. Make another matrix. So go to second and matrix, go to edit, press 2, and I want you to enter this one in there. And I want you to do RF and see if you get the answers that I did. So everyone do that right now on your calculator. This is from the page 2. This is also a 3 by 4. And I want you to enter them in there and see that you get the right answers and that you use the RF, and therefore you're starting to get really comfortable with doing that. So I will enter them also. 5, 0, 3, -11, and so on. When you get it done and entered and you do the RF, make sure you choose the B matrix, not the A matrix. So that's one thing, when you have a bunch of matrices in there, you have to remember which one's which. Not usually a problem when there's just like 2, but when you have like 5 or 6 in there, it can be a problem to remember which is which. And that looks suspiciously like the answers I got just rounded. If you round each of these to 2 decimal places, they're the same answers that we did before. So much easier to do with the calculator. So, okay. Any questions about using this with it? Okay. On the test, like I say, you're going to have to do one by hand, but all the rest of them do with this. And that will help immensely. So you have the right skills to use without that. This one, for instance, you should practice this one by hand, but you can also do it on the calculator to check to make sure you've got the right answers. So I'll do it anyway, check on Friday, but now you know how to check it. Even the one, when I tell you you have to do one by hand on the test, do it in the calculator too to make sure you get the right answer. And then if you got something wrong, you can go back and check it. So it's like, that becomes extra easy.